Did you watch them do everything in those plastic CSI gloves before they make your sandwich? Let me just tie up this garbage bag.
That's the book I was telling you about.
Got it. So, more serious stuff. Chapter 5. So, we're looking at categorical reasoning. That's what Aristotle called it, basically. And we might also call it set theory today. We're talking about different sets. So what are we talking about when we talk about theory of meaning, when we talk about nouns, anything we say? There are kinds of statements that we can make, that are true or false. Other things we might utter are neither true nor false, so a lot of that. But when we're talking about arguments, we're going to be looking at statements that can be true or false. So we're talking about categorical propositions. The main way of looking at these are four. If you think about it, I've talked about these before just briefly, but what we're looking at here are four statements that in relating to sets. The subject set is always on the left side, so that's always first. The predicate set is always on the right. And so we're looking at four possibilities. We're saying that all of the members of the set in the subject set are also in the predicate set, which is also referred to as the universal affirmative, because you're saying, yes, there is a relationship, and it's for all of them. So all horses are animals. Pretty easy. On the other hand, if we have no members of the subject set are in the predicate set, we refer to that as the universal negative. They're mutually excluded. No cats or dogs. Pretty easy, right? But then we could have some of the members of the subject set that are included in the predicate. So some blondes are female. Some blondes are male. So no, not all blondes are female. Would be a version of some blondes are female, and maybe also some blondes are not female, which would be a no, right? So some of the subject are not in the predicate. So these appear to be the only logical ways you could relate two sets of things together. All are, none are, some are not. And we have a name for these. We call them AEIO statements. And that comes from I affirm. So if I were a magic marker just for this opportunity, let's look at this one. So if we look at A and the I, it's actually I affirm in Latin. So affirmo, two F's. I affirm, affirmo, right? And I deny. You have the A statement and the I statement. You have the E statement and the O statement. Those, so the E statement is the universal negative. None of the members are included in the predicate. Particular affirmative, I statement, some are. Particular negative, the O statement, some are not. So you see, we use these two words as a mnemonic. Yes.
This is the square of oppositions, right?
Yes. Traditional square of opposition. If you read this whole article, you'll see why it's referred to as the traditional one, because after Professor Boole introduced a problem, and the problem is that in the relationships here, in modern European languages, at least in English, we can have a problem where the relationship here doesn't hold. And the reason for that is that this statement seems to include in English an existential requirement. In other words, there must be at least an existing S in the set S for that to be true, but that's not a requirement when you're talking about all of them. So if I talk about unicorns have a single horn. There are no unicorns, however, right? So if I say all unicorns have a single horn, and then I say that implies that some unicorns have a single horn is true, that sounds funny in English because it seems like you're saying there's actually a unicorn someplace. So it's called existential import. It has the feeling in the meaning of that, that there's actually an existing member of the set. And because of that problem, the modern version requires the square to be treated slightly differently depending on how you do it. The easiest way, and the way this book treats it, is to say, oh, just don't talk about unicorns. Don't talk about things that don't exist. Assume that there are at least some members that exist in whatever sets you're talking about. So that kind of escapes the dilemma. Because otherwise you end up with a really ugly square which says most of the relationships don't really happen, as you can see, the modern revised square. Ugly, I don't like it. So,
Can you scroll back down? What's the upside down A? Simplify.
upside down A means the same as what we'll use here as X in parentheses.
Okay.
It means for all you pick, for everything you pick. Which we won't use exactly that symbols when we get to, what is it, chapter 7? But we'll be using this instead. So they have, now if I'm talking about exactly the same S and P, the same two sets, then when I look at this square, so the square concerns the relationship between exactly the two S and P in all places. So if I'm talking about horses and animals, and I would say all horses are animals, we know that's true. If I say no horses are animals, we know that's false. Some horses are animals, well, that's true. Some horses are not animals, we know that's false. Right? So those are both on the, so they're both, the horses and animals are in all four positions. So the relationship then between those four statements holds such that if I say all horses are animals, and I say no horses are animals, those two statements are contraries. And what that means is if one of them is true, the other one is false. But it could be that both of them are false. It wouldn't be the case with animals and horses, but you could find things. I talk about all laptops are HPs. That's false. No laptops are HPs. That's false. Right. So notice they're contrary statements, they're not contradictories, because a contradictory, that would be like, all animals are horses. Some animal is not a horse. Well, if I find such an example, that is a counter argument to the truth of this statement. Because if I can find an animal that isn't, or rather a horse that's not an animal, right, that's a contradiction of saying that all horses are animals. So contradictions, if one is true, the other one is false. If one is false, the other one is true. But contraries both can be false. They both can't be true. The interesting thing about subcontraries, though, is both can be true. In fact, they often seem to be. So if I say paperbacks are inexpensive, some paperbacks are inexpensive, that's true. Some paperbacks are not inexpensive, that's true too, right? You know, so subcontraries both can be true, but both can't be false. One of them has to be true. Whereas with these, one of them could be false, both of them could be false. So you're looking at these relationships. Keep in mind, I'm not talking about all horses are animals, all cows are animals. Or comparing them on the square. No. Keep in mind that when you're talking about the square of opposition, you have to have exactly the same two terms in both positions in all four statements. That's your square, that's the square we're talking about.
Can you say that last part again?
Okay, so in order for you to be talking about the square, the traditional or the modern square for that matter, right? You have to be using exactly the same two terms in all four statements. In exactly that order, right? So don't switch horses with the other side. Don't say no horses are animals, and then say all animals are horses. I switched my terms. Can't do that either. Right? So if you're looking at and now I think what Aristotle was trying to do was describe the way we actually think. So I don't think he was creating this as a tool for us to be able to think clearer. He was describing the way clear thinking actually works, right? So when your mother says your room is a mess, you can't argue with her and say, none of the things that are my room are a mess. You must be thinking about some other room. Right? You know exactly what she's talking about, right? She says, everything that is your room is in the state called a mess in my house, right? So you know that she's not saying this, she's not saying this, but some of the room is a mess, that's true. Actually, all of the room is a mess. But there's some interesting aspects to some of that. We get into some interesting things. So this is pretty easy, I think, right? This isn't hard. It's just, unless you've looked at it before, you don't realize that educated people have been dealing with this traditional square since, 2,300 years ago. And everybody's had to remember this. The A-E-I-O is considered, that's Latin, so that would be something that came up during the scholastic period probably as a tool, but nonetheless, we're still referring to. There's all sorts of interesting histories about this, as you can imagine. So, looking at the text, you might want to think about the kinds of statements you usually make. We usually don't say things, unless you're an unusual person and have grown up in a particularly logical family, that all horses are animals. Say true things. What sort of things would you say are true? Harry Potter and the Cursed Child won a Tony yesterday. That's an A statement. Does everybody see that? Okay, something else that's true. No? Don't see it? Okay, so Harry Potter, I'm talking about a set of things that is that play,
Sure.
right? And that play is in the set of things that won a Tony Award.
I see.
See how that works?
Every play that was Harry Potter won a Tony. That's how you would phrase it.
Well, we're
For it to be an A statement.
well, when I use, essentially, this is a proper noun. I'm talking about the play.
Right.
We could, oh, you can imagine, you could get PhDs arguing over, is that really the play that won? Or is it the performance on Tuesday night last week that won it? Or what do you mean by the play? This is an abstraction. How can we come across as saying that there's a real thing that is an abstraction that doesn't really exist? I mean, you can imagine, you know, and besides, the play changed incrementally, I'm sure, as they realized, that doesn't really work, let's try this lighting, et cetera, right? So, oh my goodness, PhDs of plenty could be made over arguing over whether or not there's a real thing that exists that is that. But just cut and dry, what we're trying to say is, well, for this to be an A statement, I'm saying this is a proper noun.
Right.
And when talking about the proper noun, there's really only one of them.
Right.
And that's all of the members of the set. Wouldn't be right for me to think that, well, only some of the plays that were that name won a Tony. No.
I get it.
No, that doesn't make sense. But you can get into interesting situations, of course. I mean, it's amazing. I was reading, oh, by the way, speaking of email, I noticed, should I mention Stephanie by name? No. Yes? You emailed my son instead of me, your assignment. That's okay. He sent it to me. So that's okay.
Well, how to do that if I wrote down your email address?
You left out the S. His is exactly the same without the S.
Did I do it?
Sorry
So
about
I did
that.
that both times.
He only sent me one.
Okay.
Does he get a lot of your email?
That's happened. Yeah, because he's not,
Hold on.
he's teaches in the art department, or he has. He's quit though, he doesn't like it. He says the students, no, I don't want to say what he said. That's all right. But in any case,
Okay.
maybe he'll come, maybe it's just his ploy to try to get more money for it, I don't know.
Okay.
But yeah, he's in the art department, and I'm not. He makes weird things. Beautiful, weird things. Out of, well, in any case, so talking about email,
Okay.
I meant to remind, I'll email you that too, but, so I go to, this way. This is actually interesting. What? Do I remember this? Pretty sure I see. There we go. Okay, so I was reading this today, and I was thinking, boy, this would be overkill, wouldn't it? Let's talk about this. So beyond concepts. Now we've got people referring to unisets. Concepts, that seems like a more complex kind of thought. Now we've got people arguing about unisets, natural information. So general metaphysical picture of the world, cognition is possible because we live in a clumpy world where objects form clumps. For instance, rabbits in Gothic cathedrals form distinct clumps. So, in a sense, we're talking about a clump that we're calling the play Harry Potter, right? You know, so I'm not sure how they would talk about that. So we argue, we have names for clumps, right? So this is a new book. This is a summary of a new book that's out. If you're interested, you want to really blow your mind, read Beyond Concepts by Ruth Garrett Milliken. Not too bad, $35. Not too bad. It's that kind of. If you're interested in reading this, I can forward it to you. Or you could just go to the website. Notice they are online. So that's kind of interesting. So how do words enable us to mean what we talk about? All kinds of interesting stuff. St. Augustine, back in 440 AD, has some great stuff about language and how we first learn language and stuff. Pretty primitive compared to, of course, the way we are today, trying to figure out how we learn language and things of that sort. But still, kind of, the history of it really is even kind of interesting. So we're interpreting our everyday, ordinary language isn't framed in the way these concepts are, but, and I think this works, that essentially our statements can be interpreted and framed to fit these patterns. There are some specific problems that we have with regard to verbs that have relationships. So for example, if I gave you the book, if I gave you the book, the way I would have to handle it is by saying, I'm in the set of things that's the subject, and you're the one that's being given the book, something like that. Right? I'd have to do that. So I'd have to be very creative in figuring out how the predicate reflects a set of things, right, in a statement like that, or something that's actually, he gave me the book. He gave me the book. Lent me the book, right? So that's kind of interesting. Right? He being in the set of things, it's Matt, right? No, I'm getting confused. JD, John. Your name is? Anima? You're emailing the right person. I've got your email. Amity? I should be, we've been in class together before, so you're?
Joe.
Joe. So there are two Joes in here, I think. No? Not everybody's here tonight. Which, by the way, is really confusing. Not everyone is here tonight. Strictly speaking, that sounds like everybody that exists isn't here tonight. That would never be the case. If we were all here, and I said everyone is here tonight, that in a sense would be true, because I'm referring to, of course, everyone in the class. But on the other hand, if I type that into a computer as a code, right, the computer would have good reason for thinking I'm talking about everybody that exists in the world, which couldn't possibly fit here in the room, right? So part of what we're doing in this, by the way, is in being good fluent speakers. There could be a bad fluent speaker, I don't know. But being a fluent speaker, knowing how to interpret the message that the person is actually trying to transmit, right? So that you know whether it's true or false, right? We're going to have to do some finagling here in order to make sure we get it exactly right. Right? But so an A proposition, I proposition, E proposition, O proposition. And these are arranged, not on this page, but on the page that was back there. So, there we go. Standard form. Standard form. So there's just, the standard form requires you to put the all, some, no, or some are not, in exactly that arrangement for the standard form. Which gets into issues, of course. As we nice profile here on Aristotle. Aristotle, Aristoi means best, and telos means purpose. So Aristotle's name, I think, is actually a title for best purpose. He's arranged his philosophy to be the best, it's the best order. So I think his name literally means the best order. He's the philosopher who has the best order. That makes sense. Plato is a nickname for a philosopher named Aristocles, which is again Aristoi the best and Cles the glory of. So Plato, Aristocles. Plato means broad. There's lots of arguments of why his nickname was broad. Because his head was fat, his shoulders were broad, he was fat, whatever, Plato. Same as plate or plateau, right? But Aristocles apparently was his given name. But I mean, how do you get that? His philosophy is the glory of the best. It's very elitist. So all those names seem to actually describe what they accomplished. Even things like Pythagoras. Pith means to speak out. Agora means the marketplace. So Pythagoras preached at the marketplace. Perhaps. Can't really. It's like Moses in Hebrew. Moshe apparently means to lead out. Right? Duh. What is Moses famous for? And getting pulled out of the river. Pulled out of the river by Pharaoh's daughter, right? So, also interesting, Ramesses the Great, the Pharaoh, Ra Moshe, basically means out of Ra. So like he's the voice of Ra. Just interesting stuff. I get the impression that all of the names of the greats in the ancient times were named for what they accomplished, as opposed to, what do we call this?
Kevin.
George, Kevin, Aristotle. I don't know where they came up with their name. I think it was more like in the movie, do you remember the Little Big Man? He got his name because he was little, but his heart was big or something like that. Right? So we'll call him Little Big Man. Interesting. Get a name for accomplishing something. Okay. So on page 187, they give you where these come from, AI, IO, AE, etc. And they base it on Aristotle. I never heard that before until I read this book. I've always heard it as affirmo and nego, which works too. That could be both. Do we need to do some exercises? If I were to say, this is page 187, some public schools are not schools meeting national standards for excellence. That's a O statement. All malicious murderers are evil people. A statement. What if I said all malicious murderers are not evil people? What would that be? E would be screwed up, actually. Because what I would have had to have said for it to be standard form is no. Well, what would I have meant by it? And that's the problem. I've been trying to say no evil people are malicious murderers. Okay.
Oh, but then you're
Or,
swapping.
was I trying to say, some malicious murderers are evil people, and some malicious murderers are not evil people?
That would be
I know, yeah. So the problem with, if you step out of the actual form that it's supposed to be, ambiguity comes in, and we don't really know for sure exactly what you're trying to say. That's why the standard form is so fixed, that you know precisely what you're trying to say. So as as an interpreter of the argument that someone gives you, trying to put it into standard form, your skill at knowing what that person's really trying to say is important here, so that you figure it out. And by the way, they might be confused, they might be ambiguous, and not know themselves what they're actually trying to argue. And so putting it into standard form will clear it up. Are you saying this or this? Now that often happens. When you said such and such, did you mean to say this or this? You hear that coming up. Okay. But other aspects of the square, quantity, quality, and distribution. Of course, this would be where we would get quantum, qualitate, that's German, sorry. What the heck is quality in Latin? Qualitas, I guess. And distribution. So quantity, how many? And the quantity is two, it's either universal or particular. And so this, I'm talking about all the members of the set. If I'm talking about this, I'm talking about at least one, but maybe many, maybe most, maybe even all, I just don't know. All the bears in the woods are brown bears. I don't really know that. I know some of the bears in the woods are brown bears. Maybe all of them are. But it could be that some are black bears. Right. So it's either this or it's this. And it's based on my knowledge of what I'm actually trying to say. All swans are white. No, some swans are black. Some swans are not white. By the way, that gets into opposites, contradictions. What's the opposite of white? Bless you.
Absence of light.
Not white. Or do we say black?
Devoid of color.
What's the opposite of red?
Not red.
Not red?
Big deal.
Unread.
Unread. Reddened.
Didn't read it yet.
Yeah,
Unread.
unread. That's good.
Sorry. Remember, I've been studying philosophy since 1970. So I'm pretty screwed up. So it's hard for me to concentrate.
I can see why.
Okay, so quantity, all or some, or none, but that's, I'm still talking, even when I'm talking about no dogs or cats, that's really true. I'm talking about all of the things that are dogs, none of which are cats. So this is universal, what we're talking about, all or none, right? Talking about all the members of the set. Quality, we might, I don't know, I think this still feels odd to me after all these years. Quality is affirmative or negative. So you might say good, bad, smelly, turquoise, whatever quality you might want to talk about. But in logic, what we're talking about with quality is affirmative or negative. That's the relationship. So that's what they're talking about. They're talking about quality. And then distribution. This is really cool and really the essential part of all of this. What's happening here is all mathematical. These are mathematical sets. And when you're talking, we're actually doing math. That might not seem that way to you, because we think of language as being one kind of thing and math being another. Some people even hate math. Sorry, but when you're talking, you're actually doing math. If that bothers you, sorry. One of those things. Because you're distributing the sets. So when I'm talking about all members of S are P, I'm distributing the members of the subject set. And so if what I'm saying is true, if you know something that's true about all the members of set S, they are P. Likewise, but what's interesting is P is not distributed. I'm only distributing the subject set in an A statement. Say, for example, all horses are animals. You see a horse, you know it's an animal. But do you know much about animals because of my statement? No. There's a lot of ambiguity about animals. You know some of them have to be horses. Are all of them horses? Well, I didn't say. I didn't give you that kind of information, right? So I'm not distributing the predicate set of an A statement. I'm just distributing the subject set. So you know something about all the subject, but not all the predicate. With an E statement, however, this is a statement that gives you the most information you can give. And that's none of these are these. So I know something about all the members of the subject set. None of those are included in the predicate set. And I know something about all the members of the predicate set. None of those are included in the subject set. So both sets are distributed mathematically in an utterance of an E statement. The weakest statement that gives the least amount of information is an I statement. Because in an I statement, it says some horses are animals. So you know something about some horses, they're animals. And you know something about some animals, they're horses. Because notice, these are like reciprocal. If some animals, or some horses are animals, then some animals are horses. You could flip these two terms, and it would be equivalent. Right? If someone says some paperbacks are inexpensive, you use, oh, some inexpensive things are paperbacks. Same thing with no cats or dogs. You can flip that, and you can say no dogs or cats. No dogs or cats, no cats or dogs. They're equivalent. They're logically equivalent. For the one to be true, the other, you can flip the terms. Notice that doesn't mean it's on the square. Don't confuse yourself with that. Right? The square has to be in the same order. But as a matter of fact, if your mother says, no son of mine will ever ride a boat, no riding a boat, then goes with, you can flip it around and you realize that means you're not allowed to ride a boat if you want to be her son. That's orders from mom. But notice you can't do that with this. I can't flip these and end up with a true state. So if it's true that all horses are animals, if I flip it and say all animals are horses, that's false, as far as I know. Right? So you can't flip these. You can flip this one, and you can flip this one, but notice you can't flip this one either. Some S is not P. It's going to feel weird, maybe. But S is not distributed because I don't know something about all the members of S. But we say that not P distributes P because those members of P are not S. That's confusing because we're not talking about all the members of P, we're just talking about all the members that are not S. So that feels like a cop-out to me. But that's the way it's officially ensconced in the tradition. So you end up with a very nice little distribution thing here.
Which ones did you say we could flip? Sorry,
These two.
these two, in the corner.
E and I are equivalent to themselves when you use the converse. So I've been saying flip, but it's officially called the converse. So, might be a little confusing. Distribution is when you know something from the statement about all the members of a particular set. Distributed means it's ambiguous. So you have on page 190, you have the propositions listed, A, E, I, O. The quantity, notice the top two are universal, the bottom two are particular. Quality, affirmative, negative, and the terms distributed, subject and predicate. No distribution on I, and the predicate on O. So strictly speaking, if I know this is true, and I have the exact same two terms in all four places, then I know this is false, I know this is false, and I know this is true. If this is false, then I know this is true, I don't know about this, and I don't know about this. If this is true, then I know this is false, and I know this is true, and I know this is false. If this is true, this is going to be weak, right? I don't know anything about this. I do know that this is false, and I don't know about this. See how the relationships go? You actually end up with this whole set of relationships. Thought they gave it better. The book does, though. The book gives you more. This is good to memorize, by the way. Is that hateful?
Yeah.
I realize it's hateful, but there are some things you get to memorize. 'Twas brillig in the slithy toves did gyre and gimble in the wave, all mimsy were the borogroves and the momrats outgrave. I meant the whole thing, the whole page. Memorize the whole page. Well, maybe. Just some,
Scientific memory.
really, just
Maybe
memorize
just
at least
that
A,
right
E,
there.
I, O. That. And you'll see why. This is simple. All of this is simple, but it builds, and as it builds, you can imagine it's going to become apparently complex. But actually, as long as you keep in mind how simple each step is, everything will make sense. So, in the book, the next section talks about existential import, what that all is. I kind of just briefly mentioned that. We say that it has existential import if a proposition it has existential import if it presupposes the existence of certain kinds of objects. I don't think we really have to mess with that at the level that we're dealing with here. Basically, assume that when we're talking about sets, we have members, or existing members. We won't have to worry about abstract concepts that don't really exist. But that gives you the explanation for why the modern square of opposition and we'll do the Venn diagrams, but the modern square does away with some of these relationships, because if you're talking about something that's abstract, it might be true to say that all unicorns have a single horn, but it feels false to say that some unicorn has a single horn, because you don't actually have existing unicorns. Stephanie?
No.
See what I mean? You know, so in English we feel like, well, this is true about unicorns, but it's false to say that some unicorn has a single horn. Aristotle didn't have any trouble with that for some reason. Was it because ancient Greek didn't have that feeling of existential import?
They already had enough mythical things in their lives.
Pardon?
They already had enough mythical things in their lives. They didn't need to worry about horses with horns.
Sorry, this is a long topic, but is it just the test for this week, or do we also have quiz questions? Like,
Oh, yeah, I should give you a quiz question.
No.
Shouldn't email it to the right
Yeah.
person.
Yeah, really?
But you just got his email fixed.
Yeah.
Just keep sending it to us, son.
Yeah.
Also, for the quiz questions, how many words?
Thousands. No, I'm kidding.
Millions.
I feel like a long
It's,
week.
it's, how much fun do you want to get out of the course? You know, you can send me lots of stuff.
Yeah, but I recall you saying something like a minimum of 300 words.
That's for the
That's
test.
the test.
That's good. Quiz questions, it's, hopefully I ask you interesting quiz questions so that you feel like writing, because remember, I think of this as language learning, and the more you spend time practicing the vocabulary, the more fluent you'll become in the language, so. But I don't want you to hate me either. So I'm not going to push you to the point where you'll be angry at me, although I've read about people like C.S. Lewis and other great teachers that forced people to do all sorts of stuff, and they hated him while he was their teacher, but they loved him afterwards. But I know you guys are armed to the teeth, so you hate me now, you might shoot me. C.S. Lewis was in Oxford. This is Anchorage. Well, that's a big difference. Not as dangerous as Nauvoo. Is that right? Did I say that right? You could get killed in
Star Wars
jail.
universe?
Did I say it right? You could get killed while you were locked up safely in jail there. No. Okay, never mind. That was way out there. What are we doing? Contradictories. So this is actually pretty interesting, comparing contraries and contradictories and subcontraries. Because you use the expression a lot, don't contradict me. But when you hear that, you have to wonder, what did the person say? Was it actually a contradiction, or was it a contrary? A lot of the time it strikes me that we're using that incorrectly. It's not something you would, if your mom says, don't contradict me, you wouldn't say, I wasn't contradicting you, that was just a contrary.
I would totally say that.
That would, you know, no dinner for you. But so the reason the modern square is different is because if you take away that relationship between the alterns, notice that I should have said, these are called subalterns on this page, but you also see this is referred to as the super, and this is the subaltern. So superaltern, subaltern. So subalterns is pointing that way. But if we look at the revised square, notice that we lose that relationship. And that also does away with these relationships for the same reason. So it doesn't feel very useful at all. Lots of information on the web about all of these. never heard it called distributivity. That's weird.
Edit it.
Here's a little, and we have it in the text too. The book is very good, actually. It's just, since the internet is there and I have this screen, that's a lot easier than holding up the book. And can you see what I'm pointing at? And a lot of you don't have books, so. But Venn diagrams. Let's talk about Venn diagrams. These are really handy. So John Venn, I don't know if we have a blurb about John Venn, but he was a mathematician at Harvard.
It's on page 198.
It is on 198. Rats. I don't see it. From what I understand, Harvard Chapel has these windows. There's, oh, it's Cambridge? Oh, that's, just interesting. Now notice these are three. We'll start off though talking about just two. In fact, they start off with one. If you take statistics, if you've already had statistics, statistics uses the diagrams in a different way than we do because there's different purposes behind what they're doing with them. So if I have an A statement, so I have my subject, predicate. My A statement says all S are P. What I want to do in diagramming this with a Venn diagram is say that there are no members in set S that are not also in P. So what I do is I fill this whole section in to make it look empty. Now in statistics, they fill in the diagram to show where there is members. So if you're taking both statistics and logic at the same time, you're going to be very confused. I think that's part of what college is supposed to do to students, is confuse them. But so this is an A statement, and they will all look like that when you diagram them, because every single A statement is diagrammed exactly the same way. There's no members in set S that are not also in P. But in an E statement where I say no S is P, I fill in the overlapping area, make it look like a hole, right? See, there's nothing there. There's no members of S that are also P, right? In my I statement, where I'm saying some members of S are P, my technique is to put an X in the middle in the overlapping section to indicate that there are some members there. In my O statement, I put the X over here to indicate there's at least one member of S that's not in the overlapping section with P. So, as you look at how these diagrams are, it starts off with just full circles saying, okay, so if we have members, we have the circle. That's the set. If it's empty, we fill it in. And if I just have some members, I'll put an X. That's on page 196. So this goes into more detail than might be helpful, because it'll say if I'm looking at this, a two-ring diagram here, I have 3 sections, actually 4 if you count the outside. It's actually kind of important, because the outside, of course, is neither of them. Right? So if I'm talking about all the members of this set, or this set, and then, of course, I'm assuming there are other members of the set here, but notice section 4 is outside of that. That's members that are neither S nor P. So it's, maybe this feels harder than it is. There's just 3 sections to the diagram, 1, 2, and 3. Things that are S, things that are P, things that are both. So your A statement is this diagram here, all SRP, on page 197. It's more complex than I know. That's interesting. Oh. What the heck for that? Wait, don't go, come back, spend all your money. How about this? That's terrible. So the heck. I bet Wikipedia has a good page on them. Oh, that really helps. Hey, there's some. Okay, so this is E. This is none of the statement. I don't know what this is. They're just messing with our minds. No.
Oh, 3D.
What on earth are they doing?
Studies this. Mathematicians.
Oh, well. Well, the thing about Venn diagrams is you can have as many, an infinite number of them with all different overlapping sizes. But if we're just diagramming A, E, I, O statements, there's only these 4. So that should be actually pretty easy. It is, it's easy. So let me just stick to the book for those of A. I have it right there. This is A. In fact, on page 199, you've got all 4 of them there. The A statement, the E statement, the I statement, and the O statement. There's a page, yeah, that's what you said, John Van. Harvard math professor, right? So, conversion. I already talked about this with regard to the E statement and the I statement. We can use the conversion of these statements and know whether or not the converse is true or false on the E and the I. So notice, if I have no beer commercials or subtle advertisements, page 201. And now we use the converse of that. No subtle advertisements are beer commercials. Is that true? I'm thinking of the frog on Budweiser.
Subtle.
Aren't those
I mean-
subtle?
I mean, anything can be a subtle advertisement for any. I mean, you just show a brand and then that's a subtle advertisement of something.
It would depend on how big the brand name will be,
That's true.
based on what the background is. If it's smaller than, say, 50% of it, then that would probably be subtle, but if it's greater than 50% of the picture.
Well, it'd be like in a movie, you see somebody drinking a Coke product.
So was that subtle? What? What about this?
When you're running with these animals, the one thing you can never do is show fear. If you lose respect for the squirrels, you will have problems during the running. You have to be faster and quicker than the squirrels. You have to have very good reflex.
You get confused because of the size, I think. They are small, I can manage them. No, that's not true, you can't.
You've seen these, right? Running of the squirrel.
You must think like a squirrel. As long as I have legs, I will run with the squirrels.
EDS, managing the complexities of the digital economy.
I've heard the running of bulldogs.
I guess you've
I
heard,
saw that.
you've seen this one,
If
right?
the media and liberals want to defend MS-13, they're more than welcome to.
This man right here is my great-grandfather. He was the first cat herder in our family.
Herding cats. Don't let anybody tell you it's easy.
Anybody can herd cattle. Holding together 10,000 half-wild short hairs, well, that's another thing altogether.
Being a cat herder is probably about the toughest thing I think I've ever done.
I got this one this morning, right here, and if you look at his face, it's just ripped to shreds, you know?
You see the movies, you hear the stories, I'm living a dream. Not everyone can do what we do.
I wouldn't do nothing else.
It ain't an easy job, but when you bring a herd into town and you ain't lost a one of them, ain't a feeling like in the world.
Imagine what that town would think
EDS, managing the complexities of the digital economy.
Wow. So those are so subtle, you don't know what the heck's going on until, of course, the end of the commercial. Where did I bring that? No beer commercials or subtle advertisements. I don't know. But the converse. So you can switch, notice beer commercials, subtle advertisements. You switch them, that's converse. So conversion is an immediate argument formed by interchanging the subject and predicate terms of a given categorical proposition. Now, the trouble is, they're not equivalent except for the E and the I statements. You can also have the obverse. The obverse is when you change the quality of the given proposition, so you switch it from affirmative to negative, and replace the predicate term with its complement, which is the non, the things out in 4. So 4 is the non, whatever. So for example, you have an A proposition. All jackhammers are weapons. So if I use the obverse of that, I have no jackhammers are non-weapons. Notice that those are equivalent. In fact, that's also the case with O statements. So A statements and O statements, you can use the obverse, but not with the E and the I. That doesn't work. You can also use contraposition. That's where this is the most complex of them. You can take a proposition, use the complement of its predicate term, and then replacing the predicate term of the given proposition with the complement of its subject. So you end up with all pencils are ink-free writing tools. Contrapositive of that is all non-ink-free writing tools are non-pencils. It's the kind of thing you'd love to use at a moment's notice, right? These are tough. There they are. You can look at them. And we have the diagrams for them. And we have the summary. Nice little box, page 205, tells you which statements you can use the converse of. They're equivalent. We have the statements that you can use the obverse of. Those are equivalent. And contrapositive, that's the A and the O. Obversion, you could obvert all 4 of them. Sorry, I misspoke. Those are hard to remember. But there you go. The traditional square and Venn diagram. So let's move on. So Venn diagrams and the traditional square. By the way, last week I finished at 9:15 because for some reason I was thinking that's when class ends. I'm wrong. It goes till 9:55. Is that right?
No.
Well, remember, for you, you can leave whenever you like, actually. I'm the one that's obligated to be here. But, oh, no, but I would. Remember, I had a top secret clearance. I'm still that way. Honesty. No, what can you do? But who would like to take a break? Anybody? Are we okay? Okay, let's take a break. Just till about 5 after? Is that good? I'll place. What would you like? Some more beer commercials?